Hi everyone, this is your math guru. In this video, I'm going to show you how to determine the value of the following expression. We have the summation of n equals to 1 to infinity of 3 over 5 all raised to the power of n plus the summation of n equals to 2 to 20 of 3 over 5 to the power of n. We have two terms, so what I'm going to do is to simplify each term and then merge by adding. So starting with the left hand side, I have the summation of n equals to 1 to infinity of 3 over 5 to the power of n. I'm going to find the value of the first few terms. So the first term, because I'm starting from n equals to 1, that means the first expression will be 3 over 5 to the power of 1. That's my first term. The second term, that will be plus 3 over 5. Now my n is 2 because that's the second term. Then I'm going to write one more, 3 over 5 to the power of 3. So this goes on to plus 3 over 5, and it stops at infinity. That means it has no end. So therefore, if I rewrite what I have, this will be equal to, I have 3 over 5 plus 9 over 25 plus 27 over 125, and then that goes on to infinity. Note that the formula for finding the sum to infinity of a GP or a geometric progression is my s to infinity equals a over 1 minus the common ratio. So starting with a is my first term, so therefore my a equals t1, which is the first term. Note that this is my t1, this is my t2, this is my t3 to infinity. So the first term will be equal to 3 over 5. And likewise, to find the value of r is my common ratio, so it's the term in front divided by the term behind. So that's 29. I'm starting with the second term, 9 over 25, divided by the first term, 3 over 5. And that's equal to 9 over 5, 25 times 5 over 3. If I simplify that further, I'm going to have 3 over 5. The other alternative is, if I don't change my expression, if I don't simplify, I can always apply the laws of exponent, such that if I have radius equals t2 over t1, that is equal to the term in front, that's 3 over 5 all squared divided by 3 over 5, 1. And we know that laws of exponents, if the base are the same, you subtract the exponent, so that's 3 over 5 to the power of 2 minus 1, which is still equal to 3 over 5. So therefore, back to the sum to infinity, start with my first term, that's 3 over 5 divided by 1 minus my radius, which is also 3 over 5. If I simplify, that's 3 over 5, my numerator, divided by the denominator, 1 minus 3 over 5, that's 2 over 5. And that's equal to 3 over 5 divided by 2 over 5. I have 3 over 5 times 5 over 2. And that's equal to 3 over 2. So therefore, I've been able to get the value of the left term, that's 3 over 2. The next step is to find the value of the second term. So for the second term, I have the summation of n equals to 2 to 20 of 3 over 5 to the power of n. So what I'm going to do here is to find a couple of terms like I did in the first example. I have in bracket, I start with 3 over 5, but note that my n here doesn't start at 1, but at 2. So therefore, that's going to be 3 over 5 squared, plus I have 3 over 5 to the power of 3, that's the second term, plus that goes on to the last term, that's 3 over 5 to the power of 20, because that's the last term there. So therefore, like I did earlier, because it's the same equation, that's my Tn for the two expressions. So I have I'm going to have my sum 2. Note that because I'm starting at 2 and I'm ending at 20, if I start counting from 2, 3, 4 until I get to 20, that's the last term I got 20 from. I have n starting from 2 and ending at 20. You will note that if I count all the terms, I'm going to have 19 terms. So what this means is I'm not having sum to infinity here. I'm having the sum of 19 terms. And the formula for that is a bracket 1 minus r to the power of n divided by 1 minus r. Note that my a, the first term, is t1. That's equal to 3 over 5 all squared. So I have that as 3 over 5 all squared, which is the same as 9 over 25. And then I have my common ratio. It remains the same. Common ratio is the term in front minus the term behind, which in this case is 3 over 5. So therefore, if I substitute my values, I'm going to have a 9 over 25 multiplying 1 minus my radius 3 over 5 all raised to the power of, I have 19 terms, close bracket, all divided by 1 minus 3 over 5. If I punch this in, I'm going to have 0,8999945 and so on. So therefore, going back to my expression, so I have therefore the summation of n equals to 1 to infinity of 3 over 5 all raised to the power of n plus the summation of n equals to 2 to 20 of 3 over 5 all raised to the power of n is equal to, we got the first one, that's 3 over 2 plus the second value 0,8945, and the total will be 2,4 to 1 decimal place. Thanks for watching. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. Bye.